So we are good to go, Raj.
All right. Well, good evening, everybody. Thanks for doing those introductions. That was really helpful to get a bit of sense of the backgrounds. So I think you'll like what we're going to talk about today. We're going to focus on deployment, which is obviously a theme through all of your kind of introductions. And we want to talk about both generally how different approaches towards it, but we want to share with you a new open source tool that really makes deployment a lot easier. Now, one of the keys for kind of making the most of this presentation is running this code with us. So we have a notebook that runs on Google Colab, which means all of you can run this in real time inside your web browsers. I'm with you. We should have, it's easier if you have two monitors. I guess if you're on a little screen or something, you might be stuck. But it's the best way to kind of reinforce what we're doing is to try to do this at the same time. But otherwise, of course, you can follow along as well as you can do this afterwards. One of the things we'll touch upon at the end, and depending on how much time we'll have, is we'll talk not only about deployment, but other things like monitoring models. And so there, if you want, you can sign up for a DataRobot account, and we'll show you how you can do that with DataRobot. But the majority of this talk is going to be focused more on just drum and deployment. All right. We have a small enough crowd that if you feel like it, either feel free to use the chat or just speak up if you have questions as you go through this. So Tim and I will kind of hand off as we go back and forth during this. And what I want to do is first just talk generally about some common deployment patterns. How do data scientists typically deploy models? What are the typical issues that happen? Then we'll jump into the hands-on part of it, where we'll actually use Drum to deploy a model, actually swap different model frameworks using Drum. Then the next piece of it is we'll spend some time talking about model monitoring, why it's important, why we care about it, and then even show you kind of how we can add that in to those Drum models as well. So part of this is we'll go for time. I know this is often deployment is an area that lots of people have an interest in, so please feel free to kind of ask your questions as we go through this. It's a lot more fun if it's interactive. This is kind of one of my favorite sayings around this is, right, your machine learning models only get valuable when you actually deploy them. And I see this in lots of organizations where data scientists build machine learning models, like some of the presenters talked about. Maybe they're doing R&D work, but the work is moving them off those laptops and getting them deployed. I think one of the presenters here was one of the audience members was from State Farm. I could tell you when I was at State Farm, it took something like a year to get a model off somebody's laptop and into production. Long deployment time. Now, since then, they've built their own automated deployment system and they've been able to speed it up. But that last mile of moving those models into production is hard. And here's the thing is, if you're a data scientist, if you're right, if you finished the boot camp at General Assembly, my guess is you've spent a lot of time thinking about algorithms. There's tons of data science resources that focus on how you build your machine learning model. But when we start talking about issues around deployment, there's not a lot of stuff. And in fact, it's becoming such a rare field, as well as such an important field, you now see a subclass of data scientists that just focus on this productionizing. So some of the titles they might use is, for example, like a machine learning engineer that heavily focuses on the data science side of working with IT for getting those models into production. So I think there's some people here that were interested in that. It's a very lucrative piece, is if you can kind of master both the data science and all the IT tools that people use and bridge that gap. All right. Are folks with me so far? Okay. Now,
it apparently still takes a long time to move models into production at State Farm, according to Rajesh.
Yeah, well, I think part of it's technological, part of it's cultural, and then there's a regulation aspect as well that we can talk about too. So yeah, as we go through this, it's always more interesting if people have other stories to share. So for some of you that are in places that have deployed models, feel free to kind of share some of your experiences as well. So let's talk about, all right, we've built this model, we've got it sitting on our laptop. we want to now get this in production. Often the way models will work is your model might connect to another application, and that application actually uses the model. Your model is the brains for making some type of prediction that's used in a larger application. Now, one way you can do this is if you're a Python programmer, for example, you can code up your model in Python, right? Use scikit, pandas, all those tools. And then you could even create a simple web app using something like Flask and put all those development tools and put that into one package and deploy that. Now, maybe it gets a little bit more complicated if your developer is using maybe another language other than Python and you want to put those together. But one way to do this is to just take all that code, throw it into one code base, and just deploy that. And it's a very simple way, but what happens with the simplicity is it has trouble scaling. Because if you think about it, the application, so you can think here like a web interface, a GUI form that you might enter in information, is very different than the predictive engine that's making predictions. Each of those might need to be updated in different ways at different times. So while you might want to, for example, update your model on a weekly or monthly basis, now you have to update that entire app on a weekly or monthly basis. Or if it's the other way around, that your model is pretty stable, but people keep changing the app, well, every time you make a change, you have to redeploy that. So tying all those together means now you have a huge code base to support, and everything has to be synced up every time when you go to update it. So lots of data scientists, for example, will like using tools like, for example, like rShiny. You can build a simple, quick web app, but we all know that the trouble gets is when you want to kind of scale out some of that stuff, if you have all the code in there for doing your predictions tied in with the web experience, the app experience. Does this make sense to people? Okay. So this is
Rajiv.
Oh, good. Yeah.
So can we ask questions? Or,
Yeah, absolutely.
Okay. So when you say about the scale out, do you mean as per the demand, do you need to spin up the servers? In that case, we use Docker Compose and Kubernetes to meet the demand. Mm-hmm. That's what we are doing as of now.
Yeah. Yes. So there's so one end of this is that scalability of what you've talked about in terms of the resources that's needed for this model and app. And there are ways, there are technologies like a Docker, like there are right nowadays you can get servers that are terabytes. There's easy ways to kind of scale that up. But here I'm talking about scalability, not just in memory. Of course, combining both those are going to have memory, but just also the logistics, the bugs, all the things to think about when you have all your things with your model and your app together in one place. Does that make sense?
Yeah, got it.
Okay. Yeah. Okay. So people will do this. They'll combine everything. This will get a quick POC running, just kind of make sure things will actually work. But the typical pattern you see in machine learning is let's separate this functionality out into two parts and have them communicate back and forth. We'll separate out the application from the model. And what this means is if I update the app, I can update the application separately from updating the model. So if I need to update the app every week, it's okay. If I need to update the model, I can update the model at different times, and it's and we can kind of keep that independently. It becomes a lot easier to maintain, and pretty much all IT infrastructure works according to this pattern. And so the way they communicate often is with a RESTful API, where then they can kind of essentially talk back and forth with each other and communicate. So this is pretty much the most common pattern you see around kind of machine learning deployment. And I'm not an IT expert, but it's pretty standard in IT to kind of use microservices that kind of use this type of pattern to integrate. Are folks with me? Is this kind of comfortable territory here, APIs? So the challenges or what we want to do now is be able to take our machine learning model, wrap that API around it So then it becomes easy to use with the rest of our IT infrastructure. Okay. Now, if we go and do this, and I think we had some people in the introductions actually mention, the go-to tool for doing this is a tool, a framework. I don't know. It's a Python app, one of those. It's called Flask. It's a very fast, quick tool to help you kind of get that RESTful API around your machine learning model. So I think most data scientists, if you ask them now, the majority of kind of quick models that they wrap is probably using Flask. Now there's other tools that are out there. I'm just pointing out Flask because it's been around for a long time, and I still see when I scan kind of the latest projects and how people are doing it, it's still a very dominant way of wrapping your models and putting an API around them. Okay, now Flask is great. It kind of it gets you a quick way. The problem is, and maybe some of the people that have been here that have done this before, is it takes a bit of work because now you have to learn this new web framework. When you get to doing different types of models, everything you're doing has to kind of be created from scratch and custom coded. If you're trying to put 5 or 10 models, if you're switching out different models, you find yourself spending a lot of time going in there and customizing everything out. It's simply just not a tool that isn't made for machine learning deployment. There's also scalability factors when you get to kind of the bigger speeds with using Flask. And that's why there's newer technologies like Nginx and uWSGI that are being used. And I love this quote that came out and it's kind of, when I talk to data scientists, right, any data scientist can deploy a model pretty quickly, right? It's not that hard to go read a blog post. You can spend an afternoon and figure out how to cut and paste your code and get something up and running, build that simple app in an afternoon. The problem is doing this reliably, right? Doing this when you have to scale from not just 1 or 2 models to 10, 100 models, when you have to start thinking about the reliability, when you want to start thinking about model monitoring, all that stuff is when kind of a lot of these paradigms that we have now kind of break down. So this is the kind of the challenge that we want to take on, is being able to kind of do something that works and that's a bit more scalable along this way. And that's why I want to introduce Drum as this open source tool that's really built as a deployment framework, and it's designed for machine learning. And we'll talk about what that means, but on a simple level, it does things like it auto detects various model artifacts. So whether you're using PyTorch, if you're using sklearn, if you're using R, it works with all of those and detects that. It's Apache 2.0 license, so it's out there. Anybody can go get it, do whatever with it. There's the kind of the GitHub repo address there. It's quick and easy to install as well. So one of the questions is, right, why are 2 guys from DataRobot talking about this? So let me give you the story about why it's there and how it fits in to us. So DataRobot has a larger MLOps product. We help companies that have models that want to manage them. They want to monitor them. They want to have challengers running. They want to measure the accuracy of those models, a lot of that stuff. But as you can imagine, going from a data scientist's notebook, some random Python files, and moving that into something that needs to be managed and monitored, that's a big jump, right? If you look, like at State Farm, I had one person actually hand me 12 notebooks as a project for a model that they had done across 12 Python notebooks that were all named Untitled. It's a huge step to do that. So one of the things is, as we were going through doing this, we developed Drum just as a tool in-house to help us, because we needed a bridge to get from all that source code, all the code that people have, into something that we could then actually govern. Now, along the way, we realized, well, wait a minute, we've got this tool here where we have this testing environment, but it's very easy to just add a little bit of these hooks in here to make this a deployment tool. And we also wanted to just have it out there to make sure, help improve its robust, make it widely available. And so that's kind of the history of this. So it was built as something that solved a problem for us, but then we looked around and said, hey, this would actually help a lot of people and it doesn't hurt our bottom line at all by putting it out there and helping make kind of a robust tool for deployment. Okay, so let's I'll walk through the high level and then I'm going to hand it over to Tim here in a second to kind of start walking through the notebooks. And what we can do at a high level is we're going to be able to take our model, wrap that API. Remember we talked about the API, and within Drum, there's options if you want to use Flask, if you want to use Nginx and uWSGI, but wrap that around, get your API, and then simply get a prediction. And we'll have even an example with a simple Flask app. And the nice thing about this is you can now deploy this model anywhere. So you can do it on your local server. If you want to do it on AWS or Azure, you can. But this is entirely within your control and just simply saves you the hassle of kind of having to set up a Flask app and kind of work your way through that. So I'm not going to go through these commands, Tim. I think it's easier to kind of have you go through it kind of in the notebook like that. All right, how does that sound? Any questions here before I kind of move this over to Tim and he fires it up? Hopefully, are folks with me and kind of understanding what we're doing?
Yeah, I have one question, I think, and anybody can answer that if they want to, right? I always like to hear about deployment horror stories. I don't know. I just think it's, sometimes it's nice to trade, battle wounds. And if anybody does have anything of interest or that they'd like to share, that issues they ran into in deploying models, or now's the time before we jump into our hands-on aspect of the session. Anyone? I was laughing, Raj, when you said somebody handed you like 12 untitled IPyNB notebooks. So this is my model that I don't know. I'm just kind of unbelievable. That's pretty funny. Well, if there aren't any like stories anybody would like to trade, so we can.
Oh, I think Henry was trying to. Oh, nope, sorry, I wasn't looking at the wrong part of the chat. Oh, go ahead.
He's been having some audio connection issues. Yeah.
So are you asking us to share our experience in deploying the models? Or?
Yeah. If you'd like to share, absolutely.
Okay. I mean, so we follow pretty much the same kind of pattern that you are telling. So what we did as part of our project, we have a code base to train the model. And once we train the model, we created a wheel package using the GitLab YAMLs. And once that particular, and we put it into a Docker image. So that is as part of the model training. And on top of that, we developed an API, a machine learning API using the Flask. And in that, we use the previous image, and basically we made use of the model that we trained in the earlier step. And on top of that, we use that particular model as part of our APIs, and we exposed it into another Docker container. I mean, we open up the port and we expose the REST service. And that is what we did as part of one of our machine learning. But still, we are new guys to do that. Still, we have to learn a lot of things.
So Josh, when you have that model in production, do you put any like any monitoring in place on top of it, or is it something that you might have like a cadence at which you follow and refresh that model, or is it just out there? Yeah,
no, so to give the complete picture of that, the architecturally what we do is we are using the database as well. So basically, whatever the model that predicts, right, it will go to that particular database. On top of that, some analyst will validate the data. Once they validate, then we have given an option for them to retrain the model. So when they click on that, automatically that will trigger the GitLab, and it will trigger the model with a new version.
Cool.
So what we did is even we further automate in such a way that whether the analyst correct the data or doesn't correct the data, it will invoke that particular step every week at one particular point of time. So the model will be rebuilt. It might have the same data as it has as the last week, or it will have some more data. But the model will be retrained, and that will be redeployed into the ML API, machine learning API, so that the ML API will get a new model.
Got it. Very cool. Thank you for sharing that. Sure.
Yeah, thank you.
Did you see the note that Brian put in, Tim? In the chat?
I did
I don't know
not.
if you. This is almost like a meme. They handed me an exe file to fix. I said, okay, where's the source code? What source code? Oh man.
Yeah.
Thanks, Brian.
That's pretty good.
It was on a diskette.
That's awesome. It's not awesome, but I mean, it's good to be able to look back and laugh at things, right?
Mm-hmm.
Cool. Well, yeah. So as we're going to go through this today, and we're going to try to make this hands-on and keep this as open as possible, just to kind of keep some dialogue going. So I'm going to start just by focusing on the repository, just discussing the structure of it, the files contained there within, and then we'll jump into some hands-on time inside a Colab. So the repository itself, there's going to be 6 notebooks contained here. All are going to be looking at using Drum in different ways. And the main thing about Drum, and this is one of the things that I really like about it, right, is the ability to sort of bring a variety of models, like, you're programming, you're building models in open source H2O, you're doing stuff in sklearn, whatever it is, being able to bring that with pretty much, in some cases, not a lot of lift, and just being able to let Drum hook into that and serve it up. And so being able to, do regression problems, classification problems, and moving into some really kind of, you'll see examples out here like wild mode, where we're taking in unstructured data and giving out predictions. And unstructured data in one context might be, hey, you're going to build graph neural networks on top of graph data. Or unstructured in the sense that, hey, I just want to be able to tell the model to generate some fake MNIST images and return them, right? So there's a lot of flexibility really in how you can leverage Drum and the models you can bring to it and sort of serve up. We're going to be focusing on this brief tour of Drum notebook very shortly, and then we'll be spending the majority of the time in the Drum model serving. The source folder is going to contain some code that you could actually execute the Flask app that I'm going to highlight about halfway through the talk. But yeah, I totally encourage, these are basically all ready to go and run in Colab. The Keras on GPUs, it's a little bit of a mess. I'm going to be cleaning that up. And I think the person that mentioned that they have deep neural nets, CNNs that they want to be running in Docker. This is an example about how you could set Drum up, to be able to leverage GPUs for inference, if that's something that you so wanted to be able to do. But yeah, so the thing within these notebooks, you click into them and there should be an open in Colab link. The Colab is just ease of running this with me in real time. Limited, no setup really at all, except for some pip installs and maybe some other installs required throughout. But I just wanted to highlight inside of the brief tour of Drum, absolutely walk through this in your own time. Just kind of going through the commands that are available and the help commands, like how to really sort of think about what you want to do with this. We'll dive into some of these functions a little bit more detail as soon as we jump into the automated model serving notebook. But at a pretty high level, right? Drum offers a lot of functionality, where we're going to be able, we could actually use Drum to fit models. We can use Drum to run performance testing, and you can see like the details of that, right? Just how long does it take to score records and how much memory is being consumed in the process. A validation check is really something that's done, once you have your model developed and you want to move it to deployment, you validate it in the sense to make sure that it can handle data, it can handle weird things with regard to your data. Built-in support right now is offered for like missing value checks, right? Can your model handle missing values? I do believe that there are more checks on the way, right? In terms of maybe handling new levels for categorical variables, or maybe understanding weird side effects about your model and the way data is being served up. You know, so there is some utility in what it offers up. And then last but not least, you know, we have a scoring methods basically. So batch scoring. And then we have a server method that serves up the model, you know, either by way of Flask or by Nginx, you know, to be able to put an API around your model and serve it up so that you can start making predictions with it. And so really, this brief tour of Drum, probably can go through it in about 5 to 10 minutes and just kind of explore it, but just trying to give you all the lay of the land with regard to how you can use Drum. Now I'm going to go into this automated model serving made easy. So it is the, which one is it? It is this second Colab notebook, Colab Drum model serving. If you go into that and open up in Colab, you will be right where I'm at. You should see a nice table of contents and Drum automated model serving made easy. So as we're going to go through this, we're going to build out a really, I don't think I said it, really simple regression model. So we're going to be leveraging, you know, everybody's old friend, the Boston housing data set. We're going to be doing a pretty simple random forest regressor using scikit-learn. The point of this exercise is not to focus on the model building. It is all going to be about model serving, you know, using Drum to sort of test out the model, do batch scoring and some other really fun stuff. And really, as we're going to go through this, just a matter of pulling in some of the dependencies so that we can get everything up and running. And the pip install, getting the Colab requirements, really just making sure that everything's going to be there as we're going to step through. So that's going to be, you know, installing DataRobot Drum and installing maybe some of the requirements I have around some of the, you know, sklearn and pandas and whatnot that might have been a different version with respect to what I built locally versus what Colab hosts. So I'm just going through and doing the updates with that. Now, this notebook, there's going to be a couple of different options through which we can serve up the model. And that's getting back to one of Raj's comments, right? You know, Flask has been a go-to service to be able to, you know, people use it a lot to serve up models. But we're also can explore using Nginx to serve up models. I don't know much about Nginx. I'm not going to like pretend that I do. It is just my understanding that that is kind of a very robust production, you know, grade sort of serving application. It's kind of a standard. I know other, you know, packages like Fast API, I think that uses something like Scarlet under the hood. I don't know the first thing about that, but I do know that with regard to Drum, offering up an option of Flask or being able to serve up the models with Nginx is going to be entirely possible. So if you do want to serve up the models with Nginx and uWSGI, you just do a sudo install of that. And we'll go through and we'll discuss like what are actually the triggers that we're going to put in play that would say, hey, either use Flask or Nginx. But it is a pretty quick install. And now all of those dependencies are out of the way. We're gonna get in and we're gonna start modeling in a fabulous 6 lines of code. So we're gonna be going in with that Boston housing data set. It's a pretty well-known data set. I'm sure anybody that, you know, has been doing any sort of data science, self-exploratory or anything else otherwise has come across it. So we are going to build a random forest regressor, and we're going to be predicting the median value of the houses within the data set. What's going to happen though is this last component is that we're going to serialize the model. So we're just going to pickle the model to disk, and we're going to do this because that is what Drum needs to do anything with the model. So it needs a serialized version of your model, and as is. You know, Raj like had hit on this before. So out of the box support for scikit-learn, XGBoost, PyTorch, Keras, PMML by way of PyPMML, and also have support for R libraries. I'm not well versed in R. I know that Keras is probably a pretty popular R package for doing ML, and that's going to be supported within Drum natively. And then when we get into non-Python and non-R, being able to support H2O open source, H2O driverless AI, as well as DataRobot code gen exports, really just with drag and drops. You know, like the caveat around the H2O driverless AI is that there is a requirement for an active license, right? So this is part of it. It's not included in automated testings within the Drum utility, but there is a requirement that as you bring you bring your driverless AI mojo, you're also bringing a license with it to serve up for Drum. Any questions so far? One of the things about Drum is that I would say, like, you know, while we might be covering 80% of the packages that people are using for ML, there's 20% that we're not capturing. And so when we find ourselves in that situation, right, there's going to be it's not going to be just a drag and drop. There's going to be a little bit of a lift that would be required in order to let Drum understand how to necessarily like hook into your model. And that's all going to come by way of a custom.py file, right? That custom.py file would have things like, how do I score the data with your model? How do I load your model? Like, what do I need to do? And so I can give you an example of what that looks like. But really, whenever you're going to be able to sort of write your custom hook, and you provide that custom hook to Drum, you really start to open up a lot of what you're going to be able to do. Now, the thing that Drum, sort of exceeds that, in my opinion, as well, is that while I'm talking about leveraging Drum for scoring and serving and all this other stuff, the thing I did not mention is that at the same time, if I have a Docker environment that I want to be able to pair with that model, I can do so all through the command line utility. So it's a matter of being able to say, like, hey, Drum, here are my model artifacts in this folder. And in this other folder is my Docker environment. And so Drum will go through the whole, building of the image, like spinning up the container, and then actually setting the endpoint up within that container, and then making that endpoint accessible so that you can start making predictions with it. I'll try to remember as we're going to go through this, to sort of highlight an example of how that all can work. Is everybody following along so far? Or Raj, anything you want to add in there that I might have glossed over? Or
no, I think it's going good. Yeah.
Great. So as my model has been trained, and as I've written that model to disk, I'm gonna have that model, that pickle, sitting right there in that custom model folder. So that's gonna be the location that I have to keep in mind whenever I'm gonna start interacting with Drum. And batch scoring, I mean, it has its function. It's still a very powerful tool to be able to do batch scoring, to be able to set up cron jobs so that you can run something every single night, being able to serve up the models and being able to use Drum for scoring purposes in a batch fashion, right? And so as I'm going to be going through and doing this is just the command to do so. I at this point in time, I haven't added any extra code in here. I'm just going to go through. I'm going to point Drum at my model artifact. I'm going to point Drum at the input data set, the data set that I want to score. And I'm going to tell Drum where do I need to write the predictions back to. And last but not least, I do need to tell Drum what kind of target is it? Is it a regression? Is it a multi-class? Is it a binary? Or is it more unstructured? And so as I'm going to do this, Drum's going to instantiate the model. It's gonna set it up. It's gonna score the data, and then it's gonna go through and it's gonna write all of the data to disk. And then we can go in and just sort of peek at it and get a preview of exactly what it's gonna look like. So we went through, scored the whole data set, and just pumped the data back in via pandas, and just to take a peek right at the head of the data set. And I see that it's scoring. So now is when we start to get into the, a little bit more advanced usage, and that's going to be when we're going to start the inference server. And so when we're going to go through this, just so that we don't lock up the interpreter within the notebook, we are going to use subprocess. And so the subprocess will just allow us to sort of, spin it up in the background and then, interact with it and continue to leverage our notebook. And then we'll terminate everything once we're complete.
Yeah,
But
the downside of the sub-process is it makes the notebook more complicated than it actually is in actuality.
It does.
Yeah.
It does. Yeah.
Yeah, but at least you can run it all in the notebook though. But
yeah, I mean,
like actually run it outside the notebook, it's simpler. Yeah.
Absolutely. There's probably a better way to do this that I just don't know, right? But I mean, nothing too fancy will be happening. So we're going to be leveraging requests just to talk to the model. We're going to be doing just some pretty printing and, creating some byte streams so we can pass data back and forth. But this is the main function that we're going to execute. And I kind of want to walk through this just so that everybody can see what's going on with this. So I'm going to start up Drum. I'm going to start Drum up in server mode. And there's a consistency across any way that you're going to interact with Drum. There's typically going to be that code directory argument, right? Where it's a matter of being able to point the Drum at the model artifacts. So as we're going to start this up in server mode, I'm also going to point it at the directory. I'm going to give a specification for the address. I do want to see some performance information, telling Drum what the target type is, as we did before. Currently just setting the logging level for info and showing the stack trace and being very verbose. These last two commands here, this is what's going to set apart us using Flask or us using Nginx with uWSGI. So that production line right there, that's going to make sure that we're going to be leveraging production grade server to sort of serve the models up. The benefit that comes along with that is that we're going to be able to support, concurrent requests against that model once it's sort of out there in prime time. And that's exactly what I'm going to be controlling with, the total number of max workers. If I do not provide this detail, Drum will default to the Flask server and leverage that to sort of serve up the model, right? For our purposes, we really don't need Nginx for anything, but if you do want to go through and complete this exercise with Nginx, you're more than welcome to knock yourself out with that. But those are the components, and you would have to obviously be required to set the total amount of concurrency you want to be able to support with your server, and it has to make sense. Any questions on that so far?
So, do you have an extra comma at the end of that line or not?
I beg your pardon?
So, Tim?
Yes, I can hear.
Oh,
yeah.
Finally you can hear me. Okay.
Hey, Henry.
Oh, so, well, this is the deployment, but during the deployment phase, you don't, well, what I want to say is the model, you don't do automatic model choice, right?
So DataRobot does do that, but we are focused on the post development aspect of that model development exercise.
I see. And also after deployment, the model might become stale. It's out of date. You calibrate or update?
What we're going to do, and like Raj is going to pick this up momentarily to sort of have a talk through about monitoring the models. But like when you think about everything that we're working through right now, and sort of like thinking about like a refresh, schedule, it's going to be really powerful when you start to thinking about deployment, pairing that with monitoring of the models, and then pairing that with some sort of like, I'll call it a curriculum, because there's like a way that you want to sort of think about, I need to think about retraining my models. I need to think about keeping my models fresh, keeping my models, as soon as they start to degrade. I mean, because it's the one thing you can be certain of in life. And it's such a stale joke because I tell it all the time, but like, right, you're born, you pay taxes, and you die. And if you happen to be doing ML and you build models, those models will go bad. I mean, it's just a matter of life, right? So we'll spend some time discussing some of the monitoring, and happy to talk through, you know, some of that, like retraining schedules as well.
Gotcha. Thank you.
Yeah. Very cool. So yeah, right now all I'm doing is I'm kicking off the inference server with this command. So it's gonna start it up. And if I happened to have the production workers and the max workers, I could certainly check the status of Nginx to see if it's running. Right now, though, we'll see that it is not running because I'm just using Flask for the server in the background. So the endpoints that we're going to expose, so there's probably, I think there's 4 endpoints that we expose with drum. So there's basically just a ping, you know, just get the status. There's going to be a predict method. I think that there's going to be like a get stats method. So you might be able to see some of the information about, you know, usage of the model. And I think that there's one more that I'm just absolutely drawing a blank on. But in events like that, I would probably just go focus on the documentation on github.com, DataRobot user models. And a lot of the detail that I'd probably be usually looking for is going to be available within that custom model runner folder, where this is really the tool that we're going over today, and you know, the source code there for it, as well as some documentation. So I'll go through and just ping that server to make sure that it's up and running. Typically, like, I would have gone through like a lot of testing to make sure that the drum would be able to hook into it, and that it was going to be able to start it up and serve it. And I would have done that with these performance tests and these validation functions that also sit within drum. I probably wouldn't be testing it with just straight out of the box and going through server. One of the things that the validation tool does is that this is where we go through and, you know, we'll do like, hey, can your model handle missing values? And it's going to take your model, it's going to serve it up, you know, it's going to start up a server to serve your model and expose it. And then it's going to just hit it and make sure that it can hit it, it can score, and that can also handle missing values. So I would have done a lot of that stuff ahead of time, but I know this is going to work. And so I know what to expect as we're going to step through this. So when I'm going to start to send my data to the inference server, it's going to be expecting form data. So all I'm going to do is I'm going to pump my data frame. I'm going to set it up. I'm going to, you know, just create a byte stream here and pass that in to the predict route of the API that's currently available. And this is going to be my scoring function. And so the reason I'm calling this out very specifically here is that I'm going to have a little bit later, when we go and take a peek at my my pretty simple Flask app, the score function is going to reside within the app. And I'm going to show like how we can, you know, use drum to serve up the model and use a score method like this within the app to sort of reach out to the model and say hello, get some predictions. So as I have this score function ready, all I'm doing is I'm reading in my inference data set, and I'm passing that data frame into that score function, and I'm, you know, just going to be getting back a straight up, you know, request. Going to parse that out to JSON, and we're going to print out those requests. We're going to print out those predictions. So as is predictions, and it's coming back with a list of doubles because I have a regression problem. In events, you know, if I had like binary or multi-class, it would come in a slightly different structure, right? You'd get your class labels with the associated probability. And then when you move into the unstructured mode, since it's unstructured, it's going to be defined on what you want. And we can certainly take some time and show some examples of what that might look like. Again, still, I'm just going to be pinging that server. I don't know why I had that step in here. And last but not least, I'm just going to go ahead and terminate this. So I'm going to just terminate this. I'm just going to take a look at some of the details in here. So I was running that server, that Flask app server. And yeah, and everything is pretty much ready to go. And last but not least, I'm just going to call a shutdown of that model. And I don't know why I just did that, because when I terminated that sub process, that termination killed the server. So I'm gonna hop over right now just to kind of go through a simple walkthrough of what that looked like inside of that Flask app. But I do want to pause because I do have a tendency to talk an awful lot. Pause if there's any questions or anything anybody want to comment on or talk through a little more.
Yeah, and just to be clear, I mean, kind of that model that I showed before where we wanted to separate the model from the Flask web app and kind of just have them communicate via an API, that's exactly what we're kind of doing in the notebook. I mean, it's one notebook, but conceptually that's the two pieces there. And we could actually take these and put these far away on other sides of the world if we wanted to, which is the beauty of this.
Yeah. So in this example, and again, this is going to be available from right within the repository. So there's a run Flask app script, and then there's a run inference server script. So I've already started up the Flask app. And again, like this is just a simple form. I'm just going to be filling out some details about my home. And then I'm going to hit the submit button. Submit's going to make a prediction. Well, it's going to make a prediction by sending the data to my inference server and then getting the the return and then posting it to the screen. But my inference server isn't currently running. So right now I'm going to start up my model with model I built within open source H2O. So I have a Mojo exported. It is sitting in that in that file directory. So and as soon as I'm going to execute the inference server locally, we can see that it's going to start up. The details are available. Last but not least, I do see that, hey, this is a development server. It shouldn't be used in production, blah, 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 blah. It's ready to go. So now I can come back over to my Flask app. I can submit, and there, I got a prediction, 25.50. Don't really remember what that means with regard to that being a median house price, but yeah, make the submission. Now, where the real value comes in, it's like I have all these other models. Like I spent all this time building a model and I want to replace that H2O Mojo. I'm going to go ahead and kill my server. And maybe why don't I just serve up this Keras model that I developed over here? So I'm just commenting that out. I'm going to make a call out for that Keras model and serve that up just again by running that. And I got an error. Let me use one. I didn't test that one out ahead of time. So let me use one that I know that works. I'm going to use that custom model that I trained over here. I'm going to serve that up. So I loaded that in. I've hooked up. I have the server running. And now I can come back over. Same record. I'm going to send it over to the application, to the inference server. I get the return. And now I see a different prediction. So I was able to go from H2O to scikit-learn deployment, right, in a couple of fumbles, really is what I'll say, right? But that's part of the beauty of it. My app didn't have to go down at all. Obviously, if I would have tried to make a submission while the inference server was down, I would have probably gotten a 404 over here or something. But the downtime and then the uptime for this was pretty short and almost a seamless experience. Any question? Yeah, and so that's what I'm just showing here again in the notebook, really, just like, the value prop around this. So being able to, hey, take my H2O Mojo that I developed and do scoring with that. I can come over and hook into this Keras model and get all the beautiful logging detail associated with that, and then get my predictions. I can change this out for XGBoost. And again, this is going to be Python XGBoost, having that serialized and ready to go. And now I can load that in and start making predictions. And now I can jump over back to a Java-based model, and that now I can serve up my DataRobot model and do scoring with this. So with almost the same exact line of code, the only difference being the path of the directories that we went down, I was able to score same data set with 4 different models, and 4 very different models in my opinion, right? Pretty quickly. And I think, you know, Henry's question was a great question because it really gets into the whole idea of monitoring the models. And I think like the thing I've heard at some point in time is 1% of models that make it into production are monitored, which is kind of a stunning fact. And I'm going to hand it back over to Raj to start talking through like the whole idea around modeling deployments.
All right. All right. So yeah, so just kind of to recap, right? The nice thing about drum is, right, lots of different types. We didn't really show it, but there's also kind of a bunch of testing that happens that kind of folks in machine learning care about around validation and performance. Easy to get that endpoint. You can also easily containerize it and automate it. But now I want to talk about some of the other things once you have it deployed that you should be thinking about. So let me present here. And to some extent, right, we've already talked a little bit about model monitoring, and folks have kind of made it clear that that's important. This is the typical way we think about how we get predictions, right? Some data comes in, we use our models, and then we take those predictions, store them, use them someplace downstream. But if you want to, but one of the things that happens is, right, things change, right? It could be that the world has changed. It could be something like COVID, could be some gradual shift, like just, you know, how language slowly changes over time and different slang words come into place. Or really the more common thing is just somebody changed the configuration of your data, right? Your data, your variable, somebody decided to, instead of using all lowercase, decided to change the feature name to camel case. Or they decided to, instead of using the word Illinois, they decided to use the postal code Illinois. Didn't tell you or anything like that, but just decided to shove that data into your model. And of course, it's going to break. And this is why it's important to have model monitoring, because not only is your targets, what you're trying to actually predict, going to change over time, but that incoming data that you're going to use is going to shift, whether it's gradual because of societal changes or whether it's abrupt because internally you're not watching the data quality and something changes. It happens all the time, and monitoring is really important to help you do this. And you know, the key with this is recognizing that all these models are fallible. They're all going to break down. They're all going to have some type of problem. So what you want to do, and now we see lots of organizations pushing towards this. I mean, if you go and look, you'll see ML deployment is now a very hot topic. It's starting to become a very hot topic out of academia. There's lots of startups in this space because organizations, we've spent a lot of time emphasizing model development, but organizations are realizing that that's not the end of it. Once you get that model out there, you need to be able to monitor it and maintain it, because otherwise, if not, you're not going to get that promised value. Because typically what happens is the data scientist, she sits there getting the model perfect, spending time getting that AUC from 0.89 up to 0.90 or 0.91, but you deploy that model, and if you don't watch it, that that score is going to go way down very quickly. Now, when I talk to most enterprises, and this is where kind of the stories come into play, is it's really done inconsistently, even in the top enterprises, where maybe there's a couple of applications that are really super important, or maybe because of regulation, so they're somewhat monitored and there's a lot of resources that go into them, but the lion's share of models aren't monitored. Or typically the way monitoring is done as well, as soon as something breaks, okay, then we'll go and retrain, rebuild the model in that situation there. So I think what we want to do is two things. Is not everybody here is familiar with all the typical tools used to monitor models. So I want Tim to kind of just walk through the kind of the core tools that most organizations use for monitoring models around kind of drift and accuracy. And then we'll talk about how we can actually, now that we got that drum model, if you wanted to add in an agent to monitor that model, how you would do that. And what we essentially would do, kind of conceptually, and then we'll show you here, is we have drum running. What we'll do is we'll add in another library into that. That library will monitor some type of channel, whether it's your local file system, or it could be something like SQS on SageMaker, but some way to monitor the predictions that are coming out of your model. And then we can hand those off to another tool like DataRobot where they can actually be monitored, and you can do that as well. All right. So Tim, I saw you had a tab open for kind of DataRobot. I was hoping you could kind of walk people through, because I don't know if everybody's familiar with the typical tools that are used to monitor models, and if there's questions as well.
Yeah, absolutely. So, so when I start to think about, you know, the actual monitoring of the models and the dimensions around which you want to think about monitoring the models, I feel like that there's a lot of aspects in which things can start to go wrong, right? It's like you have your model, that model served up, and what's actually going on with regard to that model in terms of its service, in terms of its health there. Is it returning, you know, predictions, you know, in low enough latency that I'm meeting SLAs? Other aspects of it are going to be when you start to think about, hey, I trained my model like 3 years ago. I haven't retrained it since. Like, what does new data look like today? Chances are you're going to encounter like that whole idea of data drift, right? Data change, like the world changes, you better believe that your data is going to be changing as well. So being able to monitor what exactly does the data look like that you're seeing today versus the data that you trained the model on, right? That could help you identify issues just with regard to the state of the world. It could help you identify issues just with regard to, you know, data management and quality, right? And then last but not least, when you get into the accuracy of the model. So when you're fortunate enough to be able to collect, you know, labels for your records that you may once made a prediction on, being able to take those labels and bring them back in and show them to DataRobot and say, oh, hey, this is the actual label. What was the prediction? Well, how was it doing? And then as we go through that, there's going to be a slew of other tools that we can use and all sort of support, you know, the assessment of that model and making sure that it's a viable model once we put it into production. And so what you're looking at right now is the DataRobot MLOps product. And as you come into it, you really get like this central sort of dashboard, this pane of glass about, you know, like all the models that I currently have out there and currently have in deployment. And for each of these models, you get a pretty quick snapshot, whether or not you're looking at it from with regards to prediction health, or you might want to go through and look at it just with regards to the governance that's been put in play within the organization, right? Some models are critical. Some models, doesn't really matter if they miss a prediction or it takes 5 minutes for them to return something. So different criticality levels and different, you know, sign-off patterns that really go and play with them. And as we dive into the models themselves that are in here, we're going to be able to start to dive in and understand, what does my model look like with regard to service health? So how many predictions have I been making in the last 6 months? And what's been the average response time against those predictions? And have I seen a significant drop off or a significant spike, you know, around predictions? And being even able to say like, well, I only ever expect one person or one, you know, requester to hit this model. How many am I actually seeing, right? Definitely details that are going to be helpful, and being able to do deeper dive analysis on top of this is really going to be helpful, maybe with regard to where the requests have been coming from or some other details, you know, with regards to the service aspects. And then two, where I was talking about data drift before, this is something that's going to be entirely available on that model that we're going to, you know, deploy and associate an agent with, where we're going to be able to check out how much our data is going to be drifting and, you know, relative to how important it was with regard to the model. And so being able just to click through, and this model is performing very fine, right? There's not much drift, but being able to dive into any of the features and understand distribution at training versus distribution that I'm seeing today, to be able to go in and understand what's going on with my data, and even maybe set up notifications in the sense that I might want to receive an email every day, you know, kind of alerting me to important feature drift or service health issues, or even accuracy when I'm going to be tracking it, right? So accuracy is that other dimension where models aren't accurate. There's really no point in having those out in play. And so being able to access the accuracy once you've been able to see labels, but maybe even also having shadow models that are sort of seeing the same network data, scoring that same data. And so you might want to be able to sort of have a champion challenger sort of purpose set in play. And this current instance, I'm running 4 other models along with my, my main model that is, actually making the return predictions. So a lot of availability just in terms of understanding how healthy is my model, or what do I need to do to be able to monitor this in a pretty efficient manner. Because I don't know, like ML really doesn't lend itself to like traditional software development, I guess, like life cycle. And then when you think about what has to happen when you replace and how you monitor this and everything, there's a lot of stuff that you have to have consideration for.
I want to make sure are folks with us kind of on some of these concepts about kind of the service health and the data drift and the accuracy when we start talking about all the things you should consider when you deploy a model. Is this brand new, or is this things that people have done, or is there things that are missing?
I will say it's been my experience, and I've seen this across like large organizations, is that models aren't monitored; they're just retrained, and they're retrained at a regular cadence. So typically, it's just a lot of scheduled jobs, and so they aren't monitoring to understand data drift and service health. So potentially, retraining models when they don't need to, or whatever it is. But definitely a lot of efficiencies I think could be gained.
So question here.
Yeah.
After the deployment, I mean, if you monitor and you find something out of date, you assume it's maybe data change, maybe a distribution, it's the data change. I mean, then you need to retrain. So you tune the parameters, but could it be possible it's totally the model itself it is not proper anymore? Or maybe,
Yeah.
I mean, maybe sometimes because the model itself depend on the distribution of the data distribution, like suddenly it's not Gaussian anymore, it's something else, it's your model choice will be impacted.
Yeah.
It's not only parameter.
No, like I think about it from, I think you're getting at an issue. And the one thing I think about too, right, it's like when you start to use a model and you start to act on those predictions, right, that could also like start to have some sort of significant change in the underlying data set that you're going to be seeing, right? So I think that there's a lot of considerations, and this is really meant to sort of help, I guess, give you the starting point so that when you do get things flagged and you do need to dive in to do root cause analysis, there are a lot of tools that are available to sort of help you explore that. But when distributions change, like when you start to see like fatter tails or more peaked distributions with regard to any of your features, a lot of that stuff would start to manifest inside of the feature drift. But then you need to decide like, well, is it acceptable or not, right? Sometimes data drift is bad. Sometimes it might not be something that would mean I need to take that model, I need to take it out of commission, I need to put something else in there ASAP. So, I mean, there is still a lot of work that should be done, and obviously key risk indicators should be well understood ahead of time and established.
And this is I was just going to say, this is an emerging area of data science research. I mean, within DataRobot, at one of our paper groups, I was going to go through this paper that just came out last month called Under Specification Presents Challenges for Credibility. But it's all about these, issues of, is my model good enough? Is the data drifting? What are the techniques that I could use to help improve all of this? Go ahead.
And so when we'll go through it, like, and even with something with regard to data drift, right? So there's a lot of different ways that we can do an evaluation of drift. So whether or not we're looking at histogram intersections or population stability index, it's a lot of different metrics that are going to be available, and they're going to, your decision, right, is to decide what's going to be the most appropriate for any decisions that you want to make with regard to changes in the underlying data set, for sure.
So if you end up you have to change the model. So you need to feed it back to the development. I mean, that's what I mean. After,
so what happens next is what you're saying. Like, so once you say like, man, this model is out there and it's starting to go bad, I need to restart this whole cycle.
It's like if it's just tuned the parameter, it's okay. You just retrain it. But
right,
you suddenly you find, hey, come on, it's the model itself. Some assumptions are not right. So you need to choose the model again. Then you need to feed back some of that cycle. Is that built in the current system, or is something in the future?
Yeah, so you're getting into more of like the full blown like ML dev and ML ops aspects of DataRobot. And so when we're going through that and we're talking about taking a model and doing the deployment, but then, you know, being able to swap out those models or just be able to go in and tune, you know, some tree parameters or something like that, I would say that the tools are there to sort of facilitate that pattern of what you'd want to do, right? Because everything that we're going to be doing within DataRobot is all going to be accessible via API. So if you can kind of just think about like how you do that, like, well, do I want to take that same model and just maybe retrain it and do a new grid search on some of the parameters with more data? Or do I want to go back and explore like, you know, 50 other models? That's a decision that would have to be made, but I feel like that we can sort of like abstract it to the sense that, hey, a retraining has to happen. Is it just your model or is it a brand new model? It doesn't really matter, but we can certainly fit in there. We're not going to be taking, you know, doing scheduling inside of the platform to take the model that's currently deployed and retrain that. Like that's not something that's currently supported. But you could do this with some elbow grease API and some cron jobs, I'm sure. Like, right, where you're just going out and taking the heartbeat of the model, checking the drift, checking this, checking that, and the other thing. Once there's a violation, then there's a procedure that you would go through, you know, within your code application that would go through that entire process, and then you would just dump that model back into DataRobot ML Ops. Apologize if I'm not answering the question there, Henry.
Great, thanks.
Yep. Yeah, sorry if I didn't answer that very well. Raj, anything to add on to that?
No, I think that's pretty good. Yeah.
Okay. Cool. So
I have a couple of questions on this monitoring interface. First one is that does the entire interface that you're showing is all driven off the typical model metrics, or does the model needs to be enhanced to produce some additional data used or consumed by this monitoring?
So when we're going to be inside of Drift, and we'll be, yeah, so there's no enhancements that I would have had to have made to my model. So this model that I've developed outside of DataRobot, like that Python model, as long as DataRobot, as long as Drum can hook into it, right? So as long as it can score with it, it's going to be able to work with all of the metrics that we would expose here. So, right, so you're going to be able to go through and pursue like all of the accuracy metrics, provided that you're going to be able to capture labels, right? Data drift is not really, it's not model dependent. I mean, I guess it's model dependent in the sense that you want to only look at the features that are within the model, right? But data drift is going to happen regardless of any of the model types. So it's like, it's always going to be accessible. And I think that with regard to service health, nothing additional. I think there's going to be instances when if you have like some very, you know, like let's just say that you had some really kind of unique model. And if it wasn't supported by like, if it wasn't a scikit-learn, if it wasn't like PMML, if it wasn't XGBoost, as long as you can write a hook, right, that would tell DataRobot how to score with that model. And as long as you could write a hook to tell DataRobot how to actually load your model, everything else within here is going to work from service health, from data drift, and from accuracy for sure.
Okay, thanks. That helps. A second question is that this monitoring interface, if I were to look at the model running in a Kubernetes environment, then previously you have shown that the model along with the drum layer could be running within one container. Mm-hmm. And where would this monitoring part reside in this in the Kubernetes cluster?
So there's two there's probably a couple of different ways that you could attack this, and Raj had that slide up, right? But you could have the model that could sit in one container, and then there could be like a broker that could be like the messaging system that's going to like serve as the agent to sort of like transmit the data from the model to like to the platform, right? But when we're going to set up this agent to sort of like live where the model lives, it's just going to be a really lightweight Java app that's going to go in along with the model. Then the data is going to be buffered. Maybe the data is going to be like spooled to disk. Maybe it's going to be sent to RabbitMQ or, or SQS or whatnot. But like that aspect is going to be tied to the model. Your messaging queue could be sitting in some other container, and then everything can kind of communicate and talk back to the DataRobot platform itself. Raj, did I say that correctly? Did I mess that up?
No, I mean, I think that's, yeah, right. I mean, with the Kubernetes, right, there's a couple of things going on of measuring the overall system performance of Kubernetes as well as kind of what's going on with the model. I think it's easier if you switch to the tutorial, because then we can kind of walk through it. And if people want to, they can sign up and play with this themselves as well.
Right.
So I mean, that was part of it. I wanted to show it to you to make sure everybody understood the concepts, and then you can sign up if you want and kind of play around with it. If you want to dive in deeper on the piece.
Yeah, we're gonna go through and add agents to that model that's sitting inside of that that Colab notebook, right? And in order to do so, like I do need this tarball. This has like a new Python package that we're ultimately gonna have to install, and I'm also gonna need my API token that's gonna go along with the model. And so when I'm gonna set all of this up, right? So I have my token, I have my endpoint that's pointing at DataRobot, and I'm gonna just step through and now unpack that tarball that I've downloaded and put into sorry, I forgot to refresh. I like kept running that unzip. I kept on running that tar command, and it wasn't popping up, but I forgot I have to refresh this. So yep, as soon as I unpack everything there, I now have that new folder. So this is going to contain that agent service. It's going to contain the agent service. It's going to contain a library, a Python package that I do need to install. And that agent service is really, I do need to set that up and run it. And I will probably have to go through and configure it a little bit. The configuration is really nothing more than to tell the agent like the deployment ID, also tell the agent like what the endpoint is and my API token, and then also tell the agent how I want to buffer data, like right, how I want to buffer predictions and features and service statistics so that it knows how to communicate that information back to DataRobot. And so as I'm gonna, I don't know why I just ran that again. So as I'm gonna go through this, for the purposes, moving forward, we're going to buffer all of the data that we're going to generate with our model. I'm going to buffer it all to disk. So I'm just going to create this temp TA directory. And I do need to update my package location. Apologies. And right, all this is going to do is it's going to open up that MLOps configure file. I'm going to give it the MLOps endpoint information, my API information, and I'm pretty much ready to go. I'm going to hop over into that config file, because one of the neat things around this is that an agent service that's going to be running can be used to monitor, multiple models. And again, this is going to be the place where I'm going to configure, that buffering mechanism. So am I going to be leveraging Rabbit? Am I going to do PubSub or SQS or whatever? Or am I just going to be writing data to disk for my purposes? Well, this may not be like a realistic example. I mean, for our purposes, it's gonna work fine. But typically, yeah, the way that I've seen this happen is that you might have one container that's going to be running Rabbit, and then the agent communicates with Rabbit, and the Rabbit will communicate all the details get communicated back to MLOps. And so, oh, sorry. gotta fix my agent directory.
Did they update the version of the agent on you?
They did.
Oh, yeah, probably
That's
need to
okay.
update our notebooks.
No, that's actually not the error. Configure the location, communicate, I can't find content. Oh, they. I'm not going to screw around. I'm just going to hard code that detail right there. Oh, yeah, so that works. So yep, and so now all we'll do is we'll start up that agent service so that we know that it's going to be running. We can go through and check the status, and we can certainly go through and terminate the agent as it is running. But yeah, like the main thing to going through is just check that as the agent starts up and go in and kind of inspect the log and see what's exactly going on. And this is typically every time I want to go in and ensure stuff's running and things that are set up appropriately, I'll typically dive into the logs that will be provided, because here I know exactly how I'm going to be spooling my data. Did I connect to the client successfully, and what version of the API am I using, et cetera, et cetera, et cetera. And I know that the agent is currently running as a service right now. So that's all it takes to really get the agent set up and the agent running. And so now I do need to do just a simple install of the DataRobot MLOps library. And stuff got changed. Sorry. So yep, I'm gonna go through and install that library. And what's gonna really, what that's required for is that I need to go through and I need to register my model, which is gonna be considered an external model for all intents and purposes, right? It's gonna be a model that's gonna live outside of the DataRobot application. And when I do that, I need to essentially go through and provide some details around my model that are gonna be necessary for DataRobot when it's going to be receiving information. It knows how to parse all of that data and go through and perform all of the calcs and all of the updates that it needs to do. So the model info is the important part. Without that, I won't be able to successfully create the package. And so what I'm going to do in the next couple of steps is I'm just going to start to go through the process of uploading my training data, because, right, I want to be able to have drift associated with this. I'll go through and I'll create the model package. Then finally, I'll deploy that model package, which will return a deployment ID. And that deployment ID should be considered a live deployment. And then so I'll take that deployment ID, and that's going to be tied back to the agent service, so that when all of the data is going to be, is going to be spooled, the deployment details will be associated with that data, so that when it gets sent back to MLOps, everything will be sent back appropriately, and we'll be good to go with regard to just start scoring with our external deployment and checking data drift and service statistics and all of that stuff. Is it clear what we've gone through so far? The purpose of what we're actually executing at this point.
Thanks, Tommy.
Okay.
All right.
So this is just taking another couple minutes, because we're gonna enable the data drift as we're gonna be sending back predictions here. Can probably hop over into my DataRobot application, and now I see that model is registered within MLOps, and I can go in and I can poke around and I can explore this, right? Should not have any service health associated with this model, because I'm not making any predictions with it yet. There's going to be no data drift, no accuracy, and obviously, it should just look like an empty shell of a model right now. And yeah, I do apologize. This does take a little bit more time as it's getting everything ready to serve up the data drift information once we start scoring with it. So yeah, so now that's complete. And as it's returned a deployment ID and a model ID, That information, like I said, is going to be necessary as we're going to start scoring with our model, you know, in scoring new data with our model. Now, to actually add monitoring to the deployment, you know, using Drum, just a couple of variables that, you know, a couple of arguments that need to be presented to Drum when we're going to go through and do this. So I do need to let Drum know that, yes, I want to monitor my model. I'll have to provide my deployment ID, my model ID, as well as my monitor settings. So monitor settings are nothing more than, you know, what's your spooler type? Were you doing file system? Were you doing RabbitMQ, PubSub? And then you would provide all of the relevant details necessary to sort of support that spooler type. So you can either pass those arguments via the command, you know, the CLI, or you can set environment variables. It's easiest just to set the environment variables because we're just going to leverage the same exact code we were running previously, right? Run inference server. So serving up that custom model, and we're going to start that up, and we are going to move through and just make some predictions. Now I have predictions that have been made. I'm going to go through and go ahead and shut down my Flask server. And now I can come back over to my model, and I can start to look and start to see the service health and start to see if there's any drift. Now, I only scored maybe 100 records. We can see immediately, right? I scored 100 records across one request. It took about 14 milliseconds to complete. So it's not too troubling to me at this point in time, right? I have 100 records and it's already telling me that there's some sort of drift going on. Might be okay, might not be okay, but as I'm gonna explore this, right, I can see pretty immediately like what doesn't look good. And so as I start to see this, it's just presented by way of the drift on the y-axis and the importance of the variable, like, right? So the relationship to the target on the x-axis. And as I cycle around, I can start to see, you know, all of the variables that have been like sort of pointed at or pinged, you know, for having excessively high drift. I can start to see what's the difference here. I can see that there's a significant difference in the distribution of the data. But again, right, caveat here is that I've only looked at like 100 records. And again, so now that model could sit out there and live and breathe and make predictions, and we can continue to collect statistics and information around that model that's been deployed. But anymore, right? Because I shut down the server, I'm actually going to go through, shut down the service, and just confirm that I did successfully stop the agent service. And then the last thing to highlight here is that as we want to go through, and it doesn't always make sense to have to go into the UI and explore, you know, your model. I can certainly interact with that model via, you know, our Python client and still pull out the, you know, service statistics and data drift and have access to all of that, you know, by way of the API. And that sums it up for like that, you know, that adding that monitoring to that model that we are serving up by way of Drum. So I'd definitely stop for any questions, or Raj, anything to add?
No, I mean, hopefully people got a sense. We tried to go through this whole life cycle of taking this model, right, deploying it in many model frameworks, kind of getting it out there, being able to do a REST API, and then even adding the monitoring piece as well. So this is where kind of make sure you kind of bookmarked Tim's GitHub. You can always go check those Colab notebooks. All that stuff should just run for you if you want to kind of play around with this after this session.
Yeah, and the last thing I want to highlight, and this is going to just come back to, you know, those instances when you want to have, you know, models served up in Docker containers, right? So inside of that DataRobot user models repository, there's going to be a lot of you know, sort of starter environments, right? So environments that can support, you know, Java models, Java-based models, which would be like DataRobot CodeGen or H2O Mojos and Pojos or driverless AI Mojos, right? You know, a lot of Python 3 based, you know, framework support, as well as our language. And within here, it's nothing more than just a Docker file, some requirements, and you know, a script in play that's going to start up the Drum drum server from within the Docker file whenever you would fire it up. So it's a pretty nifty utility in my mind.
So yeah, and if you can always go to the GitHub, right? There's issues that you can open, but I think there's also like an IRC chat channel,
Yeah,
some other kind of support things for communication as well.
yeah, thanks for bringing that up. So the communication, so the IRC channel at the very bottom of the main landing page for DataRobot user models, it's a link to the IRC channel right there.
Yeah, and this is like a brand new open source project. We've only had it out for kind of a couple of weeks. I think this is Tim and I's second or third time kind of publicly talking about it. So there's still lots more to do. If people want to write blog posts and Medium articles and things like that, there's plenty of things like that that we can still do. It still haven't made it kind of a big deal about this project yet. So, or even
if you want to contribute to this, because like one of the things that I was interested in doing is getting Julia support for this, right? Because currently it's a lot of Python, it's a lot of R, and it's a lot of Java. I think Julia would be a fun one to add support in for this. And then drawing a blank on anything else that would sort of pop up as being semi-popular or useful in terms of just being able to support all the edges in terms of where people are developing models and stuff.
Very nice, guys. Hey, what was the kind of the inspiration for this monitoring part? Was that, I suspect most places probably just refresh their models, just make it a standard practice, say like on a monthly basis. But I know that takes resources and things of that nature, as some of these companies are deploying, a lot more models now. You don't necessarily have time or want to have to take them back on a regular basis.
Yeah, and one of the questions becomes like how often to set up that monitoring, right? Should you do it every day, every week, every month, every quarter, and set up that retraining? And so that's where kind of naturally, I think one of the things that happened is the feedback we get from our customers was, we initially, when I was joined DataRobot, we had the tools to give people predictions, but we didn't monitor it. But one of the questions is well, how do you retrain it? How do you know if something goes wrong? And so in response to that is kind of where a lot of this monitoring came from. Does that make sense?
Yeah, I just suspect a lot of companies, they just retrain it on a scheduled basis just to avoid the drift or any other downside issues. So.
Yeah, I do think too sometimes that there might be costs in doing that way, right?
Right.
Like, it's all like in my mind, it's like there's like the situation when you're kind of standing at the train station and you're trying to like glance around the corner to see where the train's at, like the drift, like being able to monitor that stuff up front, like you're sort of like can know it's coming up close and know like, hey, I need to be aware of this. When you get in the situation where you're like just training like once a week, there's going to be an instance where, hey, this model's been bad for like 5 days already, and I've been like making bad predictions or something, and you're kind of like, train went right past me. I didn't even know it was there, right? So I always look at it from that perspective. And there's certainly instances, and especially with a lot of the customers I support, where there's a significant cost of sort of like having like just like that monthly, daily, weekly refresh on models, depending on what their use case is.
And two other downsides of just kind of the non-reflexive retrain is, one is you need something to catch the patterns, right? If there's underlying things that are changing in your models, those are insights the rest of your organization might want to know as well. And then the other thing, like what Tim brought up, is what happens if you get a bad model? So this is where now places like Google and other places will actually have several models at one time, where maybe one model is the one doing predictions, but you have these shadow or challenger type models. And so that way, if one model isn't doing so good after a day, instead of letting it run for a week and retrain it, but after a day, maybe you switch to another model. So, these are different ways. And again, it depends on kind of the business problem and how important it is to kind of have that level of accuracy for it. But does that make sense? Like kind of those approaches?
Yeah, thank you very much.
Yeah, no, this is good.
Yeah. And just to highlight some of the interesting, I don't know, they're not interesting, but just like, non-standard uses of drum, like, right? So this drum wild mode, like this is an instance where I've paired like a SHAP explainer with my model so that now I'm going to be returning like a prediction as well as like SHAP values, right? And again, too, I was just talking about ways you deal with like, non-tabular data or not really a tabular output, right? Being able to handle everything in between. It's try to make those interesting examples. Yeah.
So, I mean, for machine learning, if you are using Python, we know you are utilizing all of the libraries, and the library that, they're written maybe in C or C++. When the CPU is running, C+ or C, it's okay. I mean, you can do very fast. But is there some cases? Are there some cases when Python just grab the CPU is running Python a lot? I mean, it's it will be damn slow.
Oh yeah.
So would that be already spotted during the development phase, or it's during the deployment phase? I mean, if it's not identified during the development phase, I mean, somehow you just see, oh my God, why is it so slow? I mean, maybe during the after the deployment, are you able to, spot that, or?
Yeah, and I can kind of like highlight that now. So one of the things that we provide within Drum is going to be some performance testing. That performance testing is just taking your data, chunking it up into different batch sizes, and seeing how long is it taking it to score it, like, how much memory is being consumed through the process of doing the scoring, right? And then, so that's going to be one of the first insights, and that's going to be when I have not gone through and have not paired that model up with anything whatsoever. So just the first insight that I get is as I'm going to be fitting this model that I've set up to be trained with Drum, I can start to see like what's my maximum memory usage as I'm going through the training process. And then as I move into the performance testing, and I'll cross my fingers that this works because I haven't visited this in a while, I'm going to go through and I'm going to start to do that performance testing where I'm going to prepare all those chunks of data. I'm going to go through and score with the model, see how long it takes, and try to understand, is it slow, is it fast, am I going to hit SLAs or not? And then from there, I mean, it really is going to be a matter of understanding the place where you're doing the scoring and where you will ultimately do the scoring, right? And if they're not one and the same, then like this performance test isn't really going to be very helpful. But I think as you move that model into production and you have complete control over the environment and going through like even simple performance tests, understand, latency is going to be, okay, you're going to have the ability to do it within like, Drum for performance testing. But in terms of using like C optimized libraries as opposed to not, that would be you handling that when you're actually, training the model or setting up the environment through which you're going to be instantiating like the serialized model. Make sure you're going to be using like optimized libraries and such, right?
Thank you.
Yeah. So this is that example I was talking about. Just went through and ran, 50 MBs of data through once to see how long it took to score and what was the maximum memory I was using for that prediction. And, so some useful utility here and sort help you along that path. It's a great point though, for sure. Any other comments or anything else anybody else would like to share? Make sure I'm not missing anything in the chat.
I think we should be good.
Cool.
This was great.
Really appreciate everybody's time tonight. Thanks for sticking around. Always like talking about this stuff.
Yeah. Yeah, give us the feedback, especially kind of, what folks would like to see for future meetups as well. We're always looking for topics and speakers, right?
Yeah, absolutely. I think this will be the last meeting for 2020. So see you 2020. Looking forward to well, who knows? Who knows? Hopefully 2021 is different. So yeah, we'll plan something for January. If anyone wants to present something, you probably have a note in your inbox from me for Chicago Mail. Just reply to that with some ideas. If you want to hear about a topic, you can just reply to that and say, I'd love to hear about something, and we'll try to recruit someone to fill that spot. So thanks to our speakers. Maybe we can all go on off mute and give our speakers a round of applause. So I'll wait until everyone unmutes. We'll see the lights flickering off here. All right. Thanks, Raj and Tim. Appreciate it.
Thank you guys very much.
Thanks, guys.
Thank you guys. Cheers.
Have a good evening or day wherever you may be.
Bye.
Thank you guys. That was awesome.
Yeah, and absolutely. If anybody has any questions or anything, obviously, please reach out.
Thank you.
Great.
All right. Thanks, everybody.
Night.
Bye.